Hey everybody, so in this video we're going to be solving this trigonometric equation. So they tell us 5 cosine of 2 theta equals 5 cosine squared minus 1. They want us to give every solution that is on the unit circle. So we're going to go from 0 to 2 pi. Now I can include 0 as a solution, but I cannot include 2 pi because of that less than sign. So the first thing that's an issue with this equation is this cosine 2 theta. So what I'm going to do is I'm going to use one of my double angle identities and I'm going to reduce this. Now, one thing you want to make sure you know, with cosine 2 theta, there are 3 variations. I want to make sure I pick the variation that uses cosine squared because of this cosine squared. So here, I'm going to say that this is going to be 5, 2 cosine squared theta minus 1 equals 5 cosine squared theta minus 1. Now, this is going to be solved just like a basic algebra problem. I'm going to distribute the 5 to both terms. So 5 times 2 is 10. 5 times negative 1 is negative 5. Here's my 5 cosine squared theta minus 1. And now I'll move this binomial over here. So 10 minus 5, that's going to give me 5 cosine squared. And negative 5 plus 1 is going to give me negative 4. And now I'll solve. I'll move the 4 over and divide by 5. So cosine squared is 4 over 5. And to eliminate the square root, to eliminate the square, I will take the square root. There we go. I'm jumping ahead of myself here. So cosine theta is the square root of 4 over the square root of 5. Now, we know what the square root of 4 is. That's 2. So this is going to be 2 over the square root of 5. And I can rationalize by bringing the square root up. So this is going to be, or equal to rather, 2 root 5 all over 5. Now, here, because we are taking the square root, we're going to have to remember our plus and minus sign. So here we want to make sure that this is plus and minus. The reason we want to know that is because we're still looking for the solution of theta. So to undo this cosine here, we're going to have to use the inverse, and we're going to have to find the inverse of positive 2 root 5 over 5 and negative 2 root 5 over 5. So here, theta is going to be the inverse cosine of 2 root 5 over 5, and it will be the inverse of negative 2 root 5 over 5. Now, these two we can do on our calculator. So because our domain is in radians, we want to make sure our calculator is in radians. So I will do the inverse cosine of 2 root 5, and I will put that all over 5, and I'm going to get 0.46. So here I have a solution of 0.46, and here I would have a solution with negative 2 root 5 all over 5. This would give me 2.68. Now, these are not the only solutions. While they're the only two that the calculator would generate. So to find the other solutions, we're going to have to look at the unit circle. So here I've constructed a rough unit circle. 0.46, this is a radian value. So we need to know, is that radian going to be in quadrant 1 or is it going to be in quadrant 2? Well, we know that it's going to be in quadrant 1. So here, this is going to give us 0.46. Now, the reason we know that is because we know that this is pi halves and this is pi. If I write this as a decimal, pi divided by 2, I'm going to get about 1.57. And we know pi is 3.14. So 0.46 is smaller than 1.57, so it goes in quadrant 1. 2.68 is smaller than 3.14 but larger than 1.57, so it's going to be somewhere over here. It really doesn't matter where I put it so long as I put it in the second quadrant. So I'll just put it here. So this is going to be 2.68. Now, because we are looking at inverse cosine here, we have to know that cosine values are the same on a vertical line. So whatever this radian value is, I'm going to have the same x-coordinate here. The reason the x-coordinate's the same is because all an x value is the distance from the y-axis. So this distance is identical to this distance. So the x value is the same. You've seen this on the unit circle. So arbitrarily, let's say I'm working with something like, pi over 4. If this were pi over 4, if this radian were pi over 4, then the x value is root 2 over 2. Well, it's at 7 pi over 4 right here, I have the exact same x value. It's root 2 over 2. So x values are the same on a vertical line. So what I need to figure out is, what is the radian value at this point? So here, what is this radian value? Well, I kind of know it. If this were pi over 6 and I went straight down, this would be negative pi over 6. Well, I know that this is 0.46. So if I go straight down, this value is just going to be negative 0.46. And it's the same over here. If this radian is 2.68 and I go straight down, then this radian here is just going to be negative 2.68. Now, while these radians are correct, they don't fit in my domain. My domain is, it has to be 0 or larger and smaller than 2 pi. Both of these are negative, so negative numbers are not going to fit. So what I need to think about is, you can imagine this like an earlier topic in pre-calculus. So here is the angle, right, coming straight down from the x-axis. So here, this comes straight down, and now I have negative 0.46 radians. Now, we know that the radian value is right, but it doesn't fit in the domain. So something I could do is, if I went in a full circle, if I added 2 pi radians, then I would get a coterminal angle that is in the exact same position. So here I could add 2 pi to this value, and that would give me a radian that fits within the range. So here, if I said negative 0.46 and then I added 2 pi, that's going to give me 5.82. Now, notice, negative 0.46 and 5.82, they're in the same place. These radians are in the same location on the unit circle. One radian, 5.82, fits within the domain, the other does not. So I can't use it. And I can do the same thing over here. I can take negative 2.68 and I can add 2 pi. So I'll say negative 2.68 and I'll add 2 pi, and that gives me 3.6. So here we'll say that this is equal to 3.6. So here are my solutions. I have 4.6 and 5.82. I also have 2.68, and across from that I have 3.6. So these are going to be my 4 solutions to this problem. All right, that's going to be all for this example. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.